Hello, so this is a demo of a proof of concept thing I've done for BitBake. The idea of it is that it exports the tasks that BitBake would run so that you can run them outside of BitBake. Now it's little more than a proof of concept at this point, but I'm going to do a quick demo of what it can do. So this is a Fedora Cloud 22 image with these extra packages which are already installed, because you probably don't want to watch lots of packages installing. And then the project I'm using as a demo is the free desktop SDK base. That's just missing off the bottom of the window, so I'll move it. So the free desktop SDK is a project making a runtime for GNOME and possibly KDE. I'm just using it as an example project here. It may not be the best example because it's a bit behind master of Pokey, the Octo reference distribution, and there's been a few issues I've hit which actually to fix them, I've backported patches from master of Pokey. But using Pokey directly is a bit more awkward. You can't do anything out of the box. You have to set up a BitBake config file and a BitBake layers file. Whereas the free desktop SDK has a nice wrapper script which we can use. Okay, I skipped some boring bits while it was cloning there. So here's the free desktop SDK repo, and it has two submodules. One is the meta OE layer, which is a separate Git repo, and one is in a Yocto directory, but it's actually Pokey, the Yocto reference distribution. And then the version they have is, I don't know exactly what commit that is. That's 1.71 plus a few commits, so it's a little out of date. I've based my patch for BitBake on this. So this is the branch. I should add at this point that there's some horrible hacks in here. This is the main patch. It's not a huge change. It adds a new module for dumping things as Python scripts and shell scripts. And that's available on GitHub at the moment. It may move. So the next thing I need to do is edit the SDK wrapper. Free desktop SDK comes with a wrapper script to run BitBake. So if I edit that, just to export tasks, this is the flag I added to BitBake into a BitBake dumps directory. And I also need to, I'm not entirely sure why this breaks things, but this causes BitBake to fail due to some changes in the Linux Octo dev Git repo. I think it's looking for a tag that isn't there. Just commenting it out fixes that problem. Then all I need to do is make some directories for the output and run the wrapper script. And so this simply sets up a config, runs BitBake. BitBake passes the recipes as normal. The code path that it's using is the normal parsing code path. Basically what the patch does at the moment is it hooks into the run queue object that would be running the build, runs through all the tasks and dumps them, and then goes onwards to the build code. It's doing something at the minute which breaks the build code and makes BitBake hang, which is some bug that I've introduced. There's quite a few warnings from parsing the recipes. I'm not sure why. I think that I've inadvertently turned on some debugging output that isn't normally written, but in a second it'll start exporting the tasks and we can look at them. So it generates a run queue just like it does when it builds. And there we go, it started dumping things to that directory I created. So this takes quite a long time, it takes about 10 minutes, but we can already start using the scripts because it dumps them in the order that it would run, that you need to run them. So I go into the BitBake dumps directory now, and there's a load of files. it will generate about 2.5 gigabytes of output, which is obviously pretty impractical, and hopefully we can remove most of the duplicated inflow in future. There's about 2,500 tasks or something. As well as dumping each task, you can attach pre-functions and post-functions to tasks, and some of these are really important, like the state post-func is actually what saves the results of the build. So we certainly need to dump those if we want the exported tasks to actually work. But that's why there's such a huge amount of different things going on just for one package. So if we look around, a simple one first. Some of them you'll see are shell scripts and some of them are Python, because BitBake lets you define either depending on what's best. So the shell script has directory set up, then it dumps every environment variable that BitBake would set when running the script. This is quite a lot of them. We need to make sure they're all set, because of course when you run configure or make, it could be using any of these variables and we don't know which, so we have to export all of them. And then at the bottom is the actual code, which in this case is really simple. One thing that really affects how useful this is that it contains a lot of hard-coded paths. So it really will only work on the system where the export was done, which is another issue. Hopefully there's a solution for that. If we look at one of the Python tasks, these are a lot bigger. So the zlib configure one is 92 lines, which is quite manageable. If we look at the code to patch zlib, there's a whole lot more state available to Python tasks when BitBake runs those. So that's like nearly 3,000 lines. And if I have a quick look, it contains logging setup, just because that's very useful when you run them, imports, and then it creates a data dictionary. This is the only thing that BitBake exposes to the Python subprocesses. Actually, that's not true. It also exposes a context dict, which we also set up. But this is the main thing. It contains every value of every variable, which is what we have set after passing the recipe that defines this task. And there's a huge amount of stuff, which is what makes the file so big. Again, this calls functions inside BitBake and other modules like the OE module, so we can't miss any of it out really, because some of it might be used. It also, to set up the functions which are set in the context, it then evaluates some of these variables, or if the value isn't available in the dict, it sets the value directly. So these are used in some of the generated code, so we have to set them up in the global, well, it's the globals dict basically, where Python stores all the global variables. And then this is the actual generated code from the recipe. Most of this is defined in the BB class, not in BitBake itself. In fact, all of this is defined in the BB class. However, you'll notice that it does call stuff in the BitBake library, and the actual patch functionality, I think, actually in the case of patching, maybe it runs Quilt itself, so there's nothing from the BitBake library in use. But in the case of fetch, for example, that's actually working hard. In the case of fetch, it's really just a wrapper around the BitBake fetcher class from libbitbake. So this could probably be simplified to just setting the source URI, but it's hard to know that in an automated way, because theoretically the fetch base class could be doing anything. So lastly, I'll show running these and show that they do actually work to a point. It will break, and when I ran this before, it broke while it was building the native bin utils, which is quite far into the build. It's actually already built the whole cross toolchain and started building native stuff. And the failure was just because of a W error. It's some compile warning, so it may just be that on this system I have GCC 5.1. Actually, it won't be that because it's using the cross compiler at that point. But it's something that's fairly easy to fix. I think this shows that the approach is fundamentally possible and that it's something hopefully interesting. So we need to set the Python path to let the Python modules that call into libbitbake find it. So I just need to remember what the paths are. So libbitbake is in there, and then liboe is in there. And if I then run the run shell script, I haven't shown you this, but it's just a list calling the other tasks that are generated in order. If I run that, off it goes. Because it has the hard-coded paths, this effectively does exactly what BitBake would do. We can have a look in the temporary directory and see it doing it. Let's see if the dump is still going, so I'll do that in another tab. So if you've used BitBake before, you'll know it has a work directory which has a whole load of saved state in there. And that's what the scripts are actually using. And the most interesting one is x86-64, temp glibc, and then the results of the build go in the sysroots. It's probably already got quilt in there. I need to wait for this instance to go. Yeah, so quilt, which is the first thing in the run queue, that's already been installed into the sysroot. And then another interesting place is the work x86-64. So this is where each package gets built. Once something is built, BitBake deletes, or these tasks delete most of the state. But if we look at the one which is building now, which is, what is it? M4. So if we look at the M4 tree, there's a whole load of stuff going on. There's the source code, which is checked out, and then there's the build. So that's the build output, like the configure output and such like. And there it is, it's still going. Now I'm not going to run this video until we get to bin utils and until we get to failure, because it'll be 20 or 30 minutes, and really you can do this yourself, hopefully.